Civil Engineering section of the Environment Unit, TMBR. So today I'm going to present to you, I'm very excited to be given the opportunity to present to you the R&D project proposal entitled Study on the Potential of Wind Tunnel Effect on Transmission Towers and the Development of Wind Hazard Map for TMB Transmission Lines. Okay. So first of all, let's go to the situation. Right now, the national grid of Malaysia is being maintained and owned by TNB with a total approximate length of 11,000 kilometers, and we are operating at 132, 275 and 500 kilovolts. They are mostly overhead lines supported by lattice transmission towers, and the national grid traverses through various types of terrain such as hilly mountains, as well as peat swamps, maybe beaches and other low-lying areas. So they may be vulnerable to certain extreme weather events. So in Malaysia, we have a Malaysian standard for determining the wind loading for building design. So basically, we use this standard to determine the wind speed and the loading for the structural design of any building, other than those caused by tornadoes and typhoons. However, this standard does not cover our transmission towers. So what we do in TMB is usually we take a basic wind speed of 105 kilometers an hour, and we apply some safety factors, and we convert this wind speed into an equivalent wind loading for the structural design. However, surrounding land use and the terrain may cause what we call the wind tunnel effect, which is a wind event higher than the design wind speed. So you may ask me, what is this wind tunnel effect all about? So this wind tunnel effect is actually a wind event which occurs when the wind is compressed between two obstacles, and it causes the wind to increase in speed considerably. May occur in areas with artificial paths or channels due to development or change in land use, and may be strong enough to cause damage or harm. For example, there's one area in Leeds, UK, which is the Bridgewater Place. There have been 25 recorded incidents of damages due to wind. In fact, there has been even one casualty due to a lorry falling over onto a pedestrian.
Wow, okay.
And then here in Malaysia, on 12 October 2014, on the Pasir Gudang Highway, a pedestrian bridge actually collapsed due to what is called an extreme wind event. So as a complication, we in TMB also has experienced an extreme wind event as I showed earlier. On 5th September 2014, 5:21 PM, two lines tripped around the same time, which is from PMU Kuantan North to PMU Gebek Industry, and also from PMU Bandar Indah Mahkota to PMU Tanjung Gelam. So both of these lines are located along the same rentis and close to each other. In fact, they are actually beside each other. And upon investigation, it has been found that several towers have collapsed. In fact, there have been 12 towers collapsed at the same area. So this is one picture.
As a result of this, at 5:31, 12 towers.
That means they found the fault at 5:21 PM. They went there to investigate, and they found 12 towers have collapsed at the same time.
So Malaysia put there, it is found that 12 towers.
Yeah, that
collapsed.
must admit too many damages to people.
No, I mean to your committee.
Okay.
The severity, yeah?
Yeah.
Okay.
So what they have found at site is mostly this kind of damages, which as you can see, the legs are practically still intact. However, they are broken somewhere in mid-length. So the suspected cause of collapse is extreme wind event based on the pattern of damage and collapse, which actually matches some other events that has happened overseas. As you can see, it's very similar. Where the legs are basically intact. Towers are all snapped midway. Okay. There are also some reports from eyewitness and also some surrounding damages around the area. So as an implication, the collapse of this transmission tower has caused the tripping and loss of electricity to customers. It has also caused a huge cost of repairs with 132 kilovolts tower, estimated 300,000 ringgit each. And then you have a loss of revenue because you cannot supply the electricity to the customers, and also it also tarnishes the image of TMB because of the complaints from the customers, and also we may be sued by other parties.
As a result of?
As a result of not
damage to property,
and also
and loss of life.
Not really. it's more we are not able to give electricity to them.
Okay.
For those in big industries.
Production stoppage.
Yeah, production stoppage.
Okay.
So, as a consequence, TMB has incurred huge costs to repair the collapsed towers. So what we need to do is we need to identify other high-risk locations along the TMB transmission line grid. So by identifying these high-risk areas, preemptive steps can be taken to mitigate the risk and to minimize the potential damages. So under this study, we have several objectives, which is firstly, we want to develop a wind hazard map based on the latest available topography, weather, and also the land use data. And then we will overlay this TMB transmission line maps into our wind hazard map to determine which areas may experience high wind tunnel risk. And then we will monitor and validate 5 selected areas using on-site monitoring and computational fluid dynamics. And then we will investigate the structural part of the towers, which is we try to correlate between what is the potential wind loading at each area and also to the capability of the tower to withstand these loads. And also we will produce the guidelines for TMBT personnel to identify these areas based on terrain and land use. As a summary of the methodology, firstly we will start the project by acquiring the latest data, land use, topography, and also weather data, and also we will combine and form a wind hazard map.
Okay.
Then we will proceed to overlay the TMB transmission line location onto this wind hazard map, and we will identify 5 high-risk areas for further study. So after we have identified these 5 high-risk areas, we will monitor these selected areas for 12 months, and also we will validate the earlier developed wind hazard map. At the same time, we will do detailed CFD modeling for these 5 sites and also determine the structural risk on the transmission line. From these 2 branches of research, we will be able to produce a recommendation on mitigation measures and also the guidelines. As I propose for this, actually for this study, we have proposed a 16-month research schedule.
16 months?
Yes, 16 months research schedule, starting with a 4-month development of the wind hazard map, followed by identifying the 5 high-risk locations. Then we proceed to simulate these 5 risk locations and also to monitor them for 12 months. Why 12 months? Because we need to monitor the whole cycle of the weather events for the whole year. And then at the same time, we will conduct the structural analysis and then produce the guidelines. So as for the committee's concerned, we will be able to at least report to the committee in 4 months' time on the 5 high-risk areas for any preemptive action that needs to be done by TMB.
It looks like you are reporting every quarter.
Yeah.
So we'll be reporting.
We will be reporting every quarter.
Every quarterly.
Yeah, every quarterly. But the most important one is this first report, which is
the 5.
Yeah,
okay.
The 5 high-risk areas first. So the deliverables for this project is the complete wind hazard map for the whole of Peninsular Malaysia, and then the detailed evaluation for the 5 locations, evaluation of the transmission tower stability, and also the results of the monitoring, and also the guidelines from the study. Okay, so for this project, we are proposing a total project cost of 1.8 million. Part of the cost is actually on the research equipment, because we need to purchase quite high-level sensors to monitor the wind speed at the areas. We will select 1 tower for every 5 high-risk areas. So we select 1 tower and we'll put these sensors at 3 locations, basically at the bottom of the tower, middle of the tower, and at the top of the tower. Yeah, we will do some prevention for that. So why do we need the three sensors on every tower? Because we need to find out the wind profile for the area. Okay. Okay. So for the benefits of TMB, through this project we can identify the high wind hazard areas So we can take precautionary measures such as strengthening, retrofitting, or the relocation of towers. And also this reduces the possibility of damages and collapse due to high winds. Okay, that's all for me. Thank you.